All right. Hey guys, sorry about the delay. I made my slides 4:3 and apparently that was a bad move, but we're all set to go now. So yeah, today I'm going to be talking about low latency SQL on Hadoop, and specifically about choosing the best option for your cluster, whether it's one you're going to buy or one that you already have in-house. A little bit of background. My name's Alan Gardner. I work for Pythian. Pythian is a vendor-neutral managed services and consulting organization. And so what that means is that I don't have any skin in this game, basically. So if I recommend an engine, it's because I looked at it, I thought it was good. So to look at the ecosystem of all of the different Hadoop or SQL on Hadoop options, there's a lot of choices. The Apache project has 4 different options right now. There's a bunch of proprietary vendors. Everyone bundles something different with their distro. And it's a little bit confusing. Out of curiosity, is anyone in the room a committer or a contributor to a SQL on Hadoop project? Anyone? Oh, we got a couple. OK, cool. So yeah, hopefully I'm right about everything. So today, we're not going to be talking about all of these because there's, like I said, a huge number. Some of them are commercial. Some of them have restrictions about benchmarking and stuff. So we're just going to look at these 4. And the rationale is that Hive is ubiquitous. Everybody has Hive on their cluster, some version. Impala has a lot of traction. It's not ubiquitous yet, and it may never get there, frankly. But at the very least, MapR, Cloudera support, and it's been widely benchmarked and widely kind of reviewed. And then Shark and Presto are kind of more up and coming, less adoption right now, but you hear a lot about them. They've been benchmarked as well pretty extensively. And Presto has that pedigree that Hive is from Facebook. Presto is also at Facebook right now, so I thought it was worth looking at. So. We're going to lead off today with performance. I did some benchmarking. I did a little bit of review of the existing landscape of benchmarks. So if you're here to see some graphs and you just want to hear which one is the fastest, we can be done in like 15 minutes. After that, I'm going to do some summary of the architecture of the different ones, the different tools, because there are 2 major approaches to SQL here. We're going to talk about the features, the different input formats supported, et cetera. Vendor support, which I think is a really important decision factor for choosing any of these engines. And then finally, some takeaways and a big chart that you won't be able to read. So to get started with performance, right now, I'm going to review a few existing benchmarks before I present my results. So the Berkeley Big Data Benchmark is a pretty good pattern. Basically, they test on a regular basis a few different releases of SQL on Hadoop engines. You can see what's listed there. And they also test Redshift, which is kind of an odd choice. But anyways, and they use EC2 instances. They've publicized all of their scripts that they use to start everything up. It was really a huge help. I've got to give these guys a big hand. They don't use TPC. They use the Intel Hadoop benchmark, which I think is kind of maybe not the most representative queries. And they use sequence files. They use about 150 gig scale factor, which is OK. But yeah, so Berkeley, unsurprisingly, finds that Shark is really, really fast. And then Impala is also pretty good, especially in more complex queries. And Hive on Tez is a distant third. Hive is way in the back. But the thing is that these guys don't actually use the optimized columnar formats right now. So Hive on Tez isn't using Orc. Impala is not using Parquet. So it's not terribly reflective of a real-world cluster. The odds that you're going to take sequence files and load them up for your low latency querying is pretty low. But I'd love to contribute. I've got some scripts that I wrote to do those conversions, and we'll probably give that back to them. So. The second that came out while I was making this slide deck, actually, Cloudera really recently did a benchmark. And obviously, Cloudera has a lot of skin in the game. And they compared the exact same options, so Impala, Hive on Tez, Shark, and Presto. Cloudera took a completely different approach. The EC2 instances that I used and that Berkeley uses, probably not representative of what you actually have in your data center. But the Cloudera ones, meanwhile, are way on the other end. They had almost 400 gigabytes of RAM per node. I think it was 12 spindles in each. So these are really beefy nodes. This is like, I would say, probably not going to reach mass adoption for a year, and if wide adoption. So these are probably bigger nodes than you're looking at buying right now. And they used a 15 terabyte scale factor for TPC-DS, which is good. That does seem really representative. So Cloudera, unsurprisingly, found Impala was the fastest by far. It was 5 times faster, I think they said, than the next best competitor, which was Shark. And they also found, and this was kind of surprising to me, but they found it outperformed Presto, both Shark and Hive Tez. And they found that Tez overtook Shark with larger data sets because the container spin up and stuff didn't matter as much. The thing is that looking at their repo, they may not have optimized the queries for Presto. Presto has some limitations that could have hurt it in this case. I'll talk about in a bit. So, but these are both, the links are in the slides, and you can go and check these out. They've got really good methodologies. You can base, if you want to do some in-house benchmarking, I'd strongly recommend using both of these as a pattern. So, for our configuration, very similar to the Berkeley benchmark. It's on EC2. It's actually using twice as many nodes with half as much resources, because personally I think that horizontal scalability is a better, more interesting attribute in Hadoop systems than being able to run on a few really big nodes, because then you just use MySQL or whatever. So those are just the specs for an M2 2x large. Only 1 spindle per system, which actually wasn't an issue because the CPUs were all pegged. So, and the versions are all there as well for the different software we used. Nothing too atypical there. It's what the Berkeley scripts will pull in by default. Choosing file formats. So this is where we really differ from Berkeley. For Hive and Shark, we used ORCFile. No big surprise. For Presto, we also used ORCFile, just because the amount of data getting read from disk for RC file was way, way bigger. I've got a slide about this after. And with RC file, I have to admit that I didn't end up testing the columnar SRD, which is the recommended best, fastest data format for Presto right now. So if you do your own internal benchmarking, try RC file with columnar SRD. They're working on ORCFile support, but I don't think it's 100% there as far as speed goes. And Impala is using Parquet with the default settings. So just a quick note, and this came up last year at Hadoop Summit too. I think there was a Hortonworks presentation that was a little bit wonky. Out of the box, orc files will be compressed with zlib, which is kind of CPU intensive, and it gets you the smallest file sizes. Out of the box, Parquet and RC file won't be compressed. So if you create the table with the default settings, you get that distribution on the left. If you specify manually that everything should be snappy compressed, you get the table on the right. The columns on the right there where orc and Parquet are similar. So in this case, unfortunately, I ended up benchmarking with the data on the left. But now you know when you go forth and do your own benchmarking, you'll be better prepared. So for my queries, chose 3 from TPCH. 1 is just filtering and aggregation on a single table. 8 is the 2 columns with many-to-many relationships, so it's joining several tables deep, which is not really a typical warehousing query, I would say. And then 10 is a fairly wide, a fairly large set of columns, and it's 4-dimension tables joined into a central fact table. So, and these are all based on the queries that came from the Hive ticket, Hive 600, which was a long time ago when they wanted to run TPCH on Hive, and they rewrote the queries. I had to rewrite 10 again to get that join order issue in Presto fixed. So we have our own version of 10 that I'll publish somewhere so you guys have access to it. And the graph. I took a little bit longer than promised to get to this, but nonetheless. So basically, it's pretty clear that Impala, can you read the scale? Impala did end up being the fastest across all of these queries by varying margins. Presto was the second fastest pretty consistently. Shark for query 1 was comparable to Presto. I know this is probably going to rile anyone who's a contributor to Shark, but Shark I could not get to run on query 8 and 10. I spent more time tuning Shark and configuring it than I did on the rest of the databases combined, and it was more difficult to get running than any of the others. So that's That's unfortunate, but in a production environment, I don't have a ton of confidence, frankly, in that. Hive on Tez was, as you can see, significantly less performant than either of the kind of MPP-style engines. And then traditional Hive, yellow Hive, which is what you get with Cloudera out of the box, was the slowest. So that's all the performance stuff. Everything else here is more of like a qualitative, why would you want to use this engine over the other engine? We've established at this point that using a dedicated MPP engine like Impala or Presto is probably going to give you the fastest query results for analytical queries, provided you meet a bunch of requirements that I'll get into. So for those of you who don't know how Hive works, just a really quick refresher. Hive 13 is going to produce directed acyclic graphs of logical query plans and submit them to and run them on Tez on Yarn. And this is obviously a big performance increase. I'm sure everyone's been to one of the Stinger presentations that's happened over the past 2 years. So you all know that there's a bunch of benefits to Tez. You can do map, reduce in arbitrary orders. You can do different partitioning schemes instead of your many-to-many shuffling. And so basically, this is a significant performance increase over the traditional MapReduce version 1 query plans. And all of this runs on Yarn. I'm kind of adopting the approach here that Yarn is going to be your be-all, end-all resource management on your cluster. That's a desirable thing. We want everyone to play nice with each other. We want to get good, even cluster utilization and make the most of our resources. So having a resource manager and being able to allocate things intelligently is good. And of course, Hive also has the nice property that your queries, if nodes fail, they'll be rerun and things like that. So this is just kind of more of a network component overview in terms of who talks to who. And yeah, it just demonstrates the same idea that basically you create an application master, and then the application master requests some resources to run the query. It's pretty straightforward. So Shark is the same architecture. Shark has been around longer than Hive on Tez. And basically the idea is that it produces a directed acyclic graph, but that graph runs on Spark instead. So Spark and Tez, Spark is a bit more mature. Spark theoretically has more features. It's better tuned for performance. And so in practice, based on the other benchmarks and the few that I got to run, Shark does end up being more performant than Hive on Tez right now. And Spark can also run on Yarn, or you have a bunch of other options as far as Mesos or standalone clusters as well. So it's a bit more flexible in terms of how you can deploy it, but as I said, the best case, I think, is the resource sharing using Yarn so that you can have a nice overview of everything that's running on your cluster and get everything to play nicely together. This is basically just what I said. The big thing that that Spark has as well are the resilient distributed data sets. And so it's possible to cache tables in memory, basically, on your nodes. With HDFS supporting in-memory caching, that's going to become less of a selling point, I think, as well. So, all right. So those are the two directed acyclic graphs, the DAG on Yarn kind of approaches. The other two engines are more of a traditional MPP. Impala, everyone probably knows about Impala here. The big thing that I want to point out is that there is a project called Llama, which basically allows for Impala to play nicely with Yarn. So Llama will sit on Yarn, it will request resources, it'll communicate back to Impala, and basically try to make sure that even though Impala is co-located on the same nodes as your Yarn workers, they're not competing for resources as directly. So this is a little bit tidier than C groups as far as spanning across the entire cluster. And for those of you who maybe tried Impala in the past and haven't looked at it recently, they have made some changes. I know when I deployed it more recently, the presence of not having to invalidate metadata anymore because there's this catalog that caches metadata and distributes it when it changes is a big plus. So this is a lot closer to just working out of the box without a lot of caveats. And the other thing is that the Impala D, you can round robin your jobs across all of them. Whichever one receives a job from a client will be the leader and basically do the query planning and things like that, so you can distribute that load a bit. Presto. Presto is really new. Presto does not play with Yarn at all. Presto just sits on its own. It does its own thing. And this is obviously a big minus if you have a relatively resource-constrained cluster and you want to be able to use it as fully as possible. So you can try to get into some C groups and stuff like that, but ultimately, this is a big downer from a deployment operations perspective. Presto also has a single coordinator, which is responsible for doing all of the planning and producing the query fragments. So it is technically a single point of failure in that sense, because it's targeted at this interactive analytical use case. It's not as much of a death sentence as, say, like your ETL engine having a single point of failure. And they've also got this discovery service, which basically is the same as the state store in Impala and just serves to keep all the nodes up to date about who is available and who's online. So now you understand all of your SQL options. The functionality I want to get into a bit. So basically, Hadoop, I think of anyways, from a data pipeline perspective, it's like a Swiss Army knife. You know, you can take all kinds of different situations, all kinds of data, munge them together, and ultimately produce something valuable, hopefully, some useful analytics, some useful reporting. And so you can kind of think of this Swiss Army knife as being the MPP engines, Impala and Presto, and then this Swiss Army knife as being Hive. So I'm going to explain a bit more about that, but basically Hive really does kind of still fulfill that promise that, you know, it can eat anything, you can extend it in every different direction, you can plug a million things into it, and the other engines support that to varying extents. So to open with Presto, Presto is written in Java, and it actually supports pluggable input formats using the same interface as Hive. So as far as I know, you can plug any existing files that you can read with Hive, should also be readable with Presto. They might not be very fast. They have some tricks that they use with RC files, but this is designed to be modular in terms of the input formats that it supports. They also support complex data, so you can have maps and arrays within your columns, but they're, the last time I checked, not very fast. So it's not a recommended use case. You don't want to use this to, you know, flatten a bunch of arrays and things like that. The UDF support is not, there's no unified interface like in Hive. You could write a UDF, but it would break between point releases. There's no support right now for adjustable splits. There's no support for kind of that Hive style where you send a bunch of data to the reducer, it handles a little bit at a time, and spills the rest to disk. And so basically your query set, your active data is still going to have to fit in memory on your nodes. And this is, as I mentioned before, there's no support for join reordering. So it doesn't matter what the cardinality of your tables are, Presto will just blindly distribute the one on the right every time. And so you really have to be careful that you put the right tables in the right spots in your joins, or else you're going to get really malperforming queries. Impala is not, and this is kind of a pain, but yeah, it's not pluggable for input formats. It's written in C. It doesn't support the same Hive interface. So you can write text and you can write Parquet, but the other formats are read-only, and when I was using 1.3.1, there was no support for orc file, which is understandable given the investment in Parquet and the optimizations and the coupling there. But it was just kind of weird to switch between Presto and Impala and see that Presto just picked up the jar file for Parquet and just ran with it. So Impala also doesn't support complex data, and it doesn't support spilling to disk either. It does support UDFs. So if you have Hive UDFs, which is probably more useful in an analytics use case, if you have some UDF that you need to use to transform your data, it'll support the existing Java UDFs for Hive as well as C-based, C-compiled UDFs. And the optimization is cost-based. It's pretty fast. So there's a real ease of querying there that doesn't exist in Presto. People can just show up and you'll get all of your push down and all of your projection. And it's much easier to work with from a end user perspective. And finally, we have Hive. So this is where the Swiss Army knife analogy kicks in. Hive is extensible. Hive reads and writes all of these common formats and any other formats that you happen to have made up at your work or home. You get SERDES. You support arbitrary, complex, nested dictionaries and arrays. You have UDFs, obviously, because my measure of UDF support is Hive UDF support. And you get spill to disk, which is obviously pretty essential for ETL when your data set is bigger than memory. You're going to need to be able to set 1,000 reducers on your 100 nodes and then have them pick up a small chunk of data, work with it, spill it someplace, pick up the next one. And Hive and Shark both support that. And additionally, they support, or they have join reordering now. So they'll use the stats that are collected in the metastore when you load your data and select the join order based on the cardinality of the tables. So that's also easier to use for querying. Vendor support. Okay, so these slides need to have like 1,000 asterisks on them because this is based on what's on the vendor's websites as of 5 days ago. So I'm not making any guarantees. I'm not making any statements about if you ask Cloudera what they'll, will you help me run Hive on Tez? I've worked with them. I've worked with MapR. Their support teams are great. Based on the documentation and based on what happens if you just try to go it alone and type things into Google, this is the very unscientific findings. So with Cloudera, you get Impala, and you get Hive, but it doesn't run on Tez. It's an okay story for the combination of ETL and analytic querying. You get the fastest, basically, analytic engine, which is nice. The lack of Tez for Hive is a little bit it's a little bit aggravating in 5.1 or 5.01 that they're on. But it's probably, it has to come at some point. They have to catch up with the mainline Hive releases. And as far as running Shark on Spark, as I said, operationally, I wasn't terribly impressed with that. I was trying to do it on Cloudera, and tuning and optimization is a real nightmare. MapR, I should note, is also backing the Drill project pretty heavily. I didn't look at Drill just because it's still in alpha. Seemingly from the documentation, it's even kind of less developed than Presto is, which is saying something. But MapR, to their credit, also have support for Impala and for Shark, and that's official. It's on their website. You can phone them up. You can read the wiki. So it's pretty straightforward to get those working. That's the one case where Shark is kind of a good idea in my mind because it's really, they've got their weight behind it. But still no Hive on Tez, and nobody supports Presto, so there's not really a differentiator. And then Hortonworks. So Hortonworks, you get Hive on Tez. It's the only vendor shipping it right now, which is great. Your ETL will be, probably at least twice as fast, possibly even faster. But the story for the fast analytic querying is not quite as strong as the others. So you're going to have to go it alone if you want to deploy Shark. If you Google Impala on Hortonworks, I can confirm there are no useful results. If someone wants to write a blog post about that, or give me a month and maybe I'll do it. But right now, that is like a wasteland. And once again, no Presto. So the thing I want to say about Presto, to Facebook's credit, it's actually really, really easy to deploy. Cloudera in that blog post kind of says, oh, it had a lot of JVM tuning and stuff. I just unboxed it and set a couple parameters according to the documentation, and it was ready to roll. And it works pretty well. So I want to say that if you're on Hortonworks especially, and it's between deploying Impala and deploying Presto, you could probably try Presto, and it won't be that hard. But you'll have to manage your own config. So you'll have to use Puppet or Chef or Ansible or something like that. But it's worth trying out, especially if your users don't mind keeping track of the cardinality of their own tables, which is kind of a tall order. So in conclusion, I've got this big flowchart, and you can't read it. But if you download the slides later, you'll find that this is actually like a real working, what's your use case, what's your vendor, what's your config like. The points that I really want to drive home are just that like Impala and Presto for most users won't be suitable for ETL. Don't try to use the same engine for everything. It's not going to work very well. Once you get one big load of data from somewhere and it doesn't fit in memory, your ETL pipeline is going to go down at midnight and everyone will be sad. So don't do that. And the other point is that if you don't have a cluster yet and you're buying a cluster, buy a cluster with a ton of memory. I think I have that on the next slide too. No, I don't. I need to put that everywhere on all my slides. If you're buying a new cluster, just load as much memory as you can reasonably afford in it because it's going to save your developers and your ops guys a ton of hassle. All of this benchmarking, everything else, it all comes down to basically you can pick an analytic engine and you can scale it until you run out of RAM. As far as other conclusions, Shark is faster than Hive on Tez. I confirm that, but not to a degree of confidence that I'm very happy with. Every other benchmark, the two that I mentioned also confirm that. But you're gonna spend some time. You're gonna bleed a little bit trying to get it going. Presto, if your users are really savvy, if the people who are going to be doing it don't mind the complete lack of like join reordering, some other optimizations, they're willing to put their own filtering in their subqueries and stuff like that, you could maybe go with Presto, and it'll be a pretty fast MPP engine, but it also won't play nicely with the rest of your cluster. And finally, Hive on Tez Impala, it works pretty well. Getting Tez working on Cloudera was not super, super easy. But in general, that should be a configuration that if you're on Cloudera, if you're on Hortonworks, or if you're on Cloudera or you're on MapR rather, you should be able to get some combination of fast Hive and Impala and be able to satisfy your ETL and your analytical needs. So that's all. Hopefully you've been enlightened. Does anyone have any questions? Do you want to come up to the mic?
You said that Presto doesn't work with Yarn. Does it require Hadoop at all? Does it have dependencies on Hadoop?
No, actually. So Presto can plug into a whole bunch of different. I didn't explore that extensively because my main field of interest is Hadoop. But it plugs into Cassandra, I believe. It plugs into some internal proprietary Facebook databases that we don't have access to. They're working on their own internal table type as well. I didn't mention this, but they're going to support caching tables to disk with the same format that they use in memory called Raptor. So Presto actually is not dependent on HDFS at all, and you should be able to run it if you want to use it as a query engine for something else. But I think HDFS is one of the prime use cases.
OK, thanks.
No problem.
So I found one surprising thing, which is Shark, which runs on top of Spark, which is in memory.
Mm-hmm.
What's your comment about why it's slower than others?
Shark being slower than others?
Yeah.
Well, Shark isn't necessarily in memory. It can read from disk as well. If you have all of your data in the resilient distributed data sets and they're in memory, then it's in memory. So you have to load all of your data into memory first explicitly, and then you can query it. I didn't actually say it was slower. I said it was faster than the other directed acyclic graph approach, which is Hive 13, like the Stinger Tez approach. The overhead of running on Spark is less than the overhead of running on Tez right now, and there's some better optimizations in there. But my complaint was mostly just with the stability, that even though Spark is GA, even though I had a cluster that supports Spark and everything, getting Shark to run and actually return results was a real hassle when I got into these queries that had multiple joins and things. So does that answer?
So was your all data in memory in Spark, or?
No, all of these were from disk. Sorry, I should have mentioned. This is without container pre-warming, and this is all from disk.
Yeah, that explains it.
Okay.
Thank you.
I'm just wondering, have you guys also looked at Apache Tajo at all, or have plans to look at it?
I saw the page for Apache Tajo. The logo was even on that first slide.
Right.
And I looked at the presentation that they gave a little while ago, and it seemed really, really interesting. Mm-hmm. I would love to benchmark it separately and just try it out. But in terms of kind of limiting the number of engines that we tested, those were the big four, and Tajo just doesn't have the momentum, I don't think, right now. But I definitely, personally, I think it's really interesting.
Right. Thanks.
I have two questions. The first question is, did you have a chance to test Apache Phoenix? And if yes, what's your impression? And the second question is Impala. Last time when I have tested it, Impala had a very nasty part. It fails if it runs out of memory. Basically, it's a very niche product. Is it correct?
So about Phoenix, I didn't have a chance to try out Phoenix. I haven't done a lot of research into it. It seems interesting. As far as Impala goes, yes, Impala and Presto, if your working set is bigger than memory, the query will fail. They're designed for interactive analytical queries. They're not designed to be part of your ETL pipeline. And so, yeah, that's why, I mean, when you see Cloudera benchmarking it, it's got 400 gigs of RAM per node on a 20 node cluster. So they've got like, what is that, 8 terabytes of RAM or something in that cluster? Like, that's kind of where I'm going with this, is that if you're gonna size a new cluster, if you haven't bought it yet, 10 gig E and as much RAM as you can reasonably afford. And you can throw something like Impala on it, and it's less niche because you've got so much room to work with, basically.
Did you say that you were able to actually integrate Cloudera with Tez and test it out? Is that what you did? It wasn't clear to me. So.
The testing in the benchmark to run Hive on Tez was using the Berkeley script, which actually runs a Hortonworks. It's an HDP cluster. So that's in the slide. You'll notice we use different distros on Amazon with the same data set to get those results. And that's the same approach that the Berkeley guys are using right now. Yeah, running Tez on Cloudera is a little bit more challenging, but I did do it on our internal cluster, so it is possible. It's just more approaching that like Shark level of you have to roll your own. It's not super fun kind of approach. So.
Do you know when it's actually coming integrated?
No, I don't work for Cloudera. I don't have any, like we partner with them, but they haven't told me anything secret. The speculation is maybe CDH6, which seems far out to me. I'd like it sooner, but oh well.
Come in late, but how did you do all that testing, all these benchmarks?
Do I have a backslide?
Sorry.
Yeah, here we go. No, that's fine. Yeah, so I mean, all of the slides are going to be available on the website. Basically, the methodology, yeah. So 9-node cluster on EC2, relatively small machines, because I kind of pointed out I like the horizontal scaling aspect better. I feel like that's more relevant for Hadoop. And yeah, but they do end up being relatively wimpy machines if you're comparing to an in-house cluster. So I'd recommend redoing this with your machines once you've got them. Yeah, these are the file formats we used, and then these are the TPCH queries, and you can see where we got them from.
Hi.
Hi.
What was the size of the data set? I didn't see that listed.
We used a 100 gig scale factor.
Okay.
Yeah, I think that's on there.
I didn't realize that's what that meant.
Yeah, the scale factor for TPC, there's a dbgen that actually generates all the test data as flat text files, and then yeah, so the flat text files were 100 gig. If we advance to this slide, by the time you get them columnar compressed, they're closer to 20 gigs.
So what was your, I guess to the gentleman who asked the two questions, what was the feedback on the overall stability and reliability of these, specifically Impala?
So I can give a little bit of, as far as stability and reliability, I'm sorry, I just killed my slides, but in my experience doing this, Presto was pretty rock solid. Like I said, I just threw it out there. I deployed it on all of the nodes. They all found each other using the discovery service. I could submit jobs. They were fast. It was fine. Impala was good. I ran into a few complaints where basically it seemed to be giving up. There was some flakiness in the network on EC2. And Impala kind of seems to maybe have this habit of being really fast or not wanting to run at all. So when it hit some kind of exceptional conditions, it just came back and complained. And I ran it again, and it was fine. So in an interactive sense, it's not too bad, you know. But yeah, it definitely, I did encounter a few hiccups there. And then with Hive, Tez, and also just conventional Hive were rock solid, no problems. Anything else?
Yeah, I got one
Oh,
here.
can you come
So
up to the-
from your graph there, looked like Impala gave the best response times, right?
Yes.
But so would you say Impala is the best or not? Because I think when you started your talk, you said Impala may not be around in 2 years or whatever. So
I said Impala may not be ubiquitous. I don't know if
Okay.
Impala is ever going to be available. If you're on Hortonworks, I don't know Hortonworks' roadmap, but I don't think that they're super great fans of Impala. Maybe someone here from there can like officially confirm that, but but I mean, as far as support with Cloudera, it's going to be available on Cloudera in 2 years. I'm pretty confident of that. And as far as analytical queries, where you only need to read the formats that I showed, and you only need the features that I showed in that matrix, it is the fastest for sure. So basically what you want to do is build out a Hive pipeline on Shark or whichever other one is available and stable, and transform your data into a format that Impala can read, and then give Impala to your end users. Yeah.
okay. And the other thing I noticed was the nodes you used were only quite small memory, 34 gig or something, right, per node. But still Impala did pretty well with that kind of cluster. So
The scale factor wasn't huge. Yeah, I mean, if you look at with 100 gig data compressed with Parquet, it could have all fit in the memory of one node. That's the one kind of sad fact of that, is that it would have been nice to be able to do. I tried a 1 terabyte scale factor initially, and that was completely unusable on Impala, obviously, because even just a single table wouldn't fit. So.
okay, so the 100 gig data set, so do you know how much it was after compress in Parquet?
Yes, it was. There's a slide about that. It was about 30 gigabytes.
Oh, 20 gigs, so it fit in memory, could fit.
Exactly, yeah.
Okay.
And it doesn't, so just to clarify that, it's only the working set. If you do filtering on the nodes and things like that, it'll do a full table scan first, and it'll only pick out the records that actually need to be used. And then it'll do, there's a few different join styles available, but basically, yeah, your whole tables, your whole data set doesn't have to fit in memory, it's just the relevant records for that query.
So you made the comment about 10 gig Ethernet, and you tested this in the cloud. What kind of evidence do you have to suggest that might help? Because RAM is a lot cheaper than 10 gig Ethernet.
Just in general, my experience, this is not based on this benchmark, but just my experience in general with Hadoop, and I think most people will agree that shuffle is really the big pain point in most jobs, and there's a whole bunch of workarounds. In the original MapReduce, you know, we have compression, we have all sorts of different things done. In the second one, they've even, or in TES, they've gone with this approach where you can tie a single reducer to a single mapper kind of and carry through like that, or multiple. So network in general is a big pain point. Yeah, when I say you should get 10 gig E, I mean you should get 10 gig E if your budget allows for it. You should probably top up RAM first. Sure. And then, but it's the way to go, I think. In a couple of years, you're gonna regret it. Okay. Thanks a lot, guys.